Hey again, Year 7s. This skill will be looking at finding the fraction of a quantity. The learning goal for this skill is to see the difference between what a fraction is and what a quantity is. And the success criteria is to be able to find the fraction or portion of a quantity through a variety of methods. I've taken a few examples from Essential Assessment for this skill just to see what you need to do. And I'm actually going to show you some different approaches to set questions. Now, again, I said in my previous video that it's easy for us to rely on a calculator to be able to get the answers just using this fraction button here. But we're going to try to stray away from that because, again, I don't want you guys to be robots. I want you guys to know the behind the scenes. I want you guys to learn what's going on to see why we get the answer, okay? And this is what a calculator can't show you. They can give you the answer, but they can't show you how the answer has been obtained. So right now, we've got a question here. We're going to calculate the fraction of this amount. So one of these amounts is obviously a fraction, and the other one is considered as a quantity. In this case here, the 1/5 is the fraction, and the 10 here is considered as the quantity. And quantity just means a whole amount, okay? It is a whole amount, okay? And you can't have quantities that can be given within a form of a fraction or a decimal. But generally speaking, quantity is divided as a whole amount, and we're going to find the fraction of a whole amount. So when it says here, calculate the fraction of this amount, they have this multiplication symbol here. And when it comes to the maths world, whenever you see the word of, we use the tool, the mathematical tool, multiplication. We use multiplication. And I'll show you why that this is the case. Right now, we're looking for 1/5 times 10. Now, in the previous video, we know that multiplication is just a form of repeated addition. So what we're doing with this is we're getting 1/5 and we're adding it to itself. We're adding it to itself 10 times. So this operation here is being applied 10 times. And this is one way of looking at it. So we can get 1/5 plus 1/5, and we can keep doing this. And we know 1 plus 1 plus 1 right up the top is going to equal 10. And the denominator, if they're all the same, will remain the same as the answer. And this will be our solution, 10/5. But this is a bit of a weird solution when we're talking about in the context of calculating a fraction amount of a quantity. Because 1/5 of 10 is 10/5. We can find a way of answering this in a better form because we know how many 5s go into 10. This is 2. This has been written as an improper fraction. Remember, improper fraction just means that the top number is greater than the bottom number. The numerator is greater than the denominator. If this is the case, we can write this in mixed numeral form, but we don't have to because we know 5 goes into 10 exactly twice. There's no remainder. So this is saying that 1/5 times 10 is 2. But if I change this times to an of, this is saying that 1/5 of 10 is 2. And that terminology wise makes more sense. 1/5 of 10 is 2. If we were to get 10, let's just grab 10 of a certain item. Let's go 8, 9, and go 1 in front here, 10. We have 10, say, footballs, and they look like footballs. And we're going to find 1/5 of that amount. In order for us to do that, we have to split the 10 footballs into fifths. And we know this to be like that. So we've now split it into fifths, and what we care about is just one of those fifths. So one of those fifths is 2, which is what we got in the previous way of solving it. So this terminology of changing the times to an of makes more sense context-wise. So we know that our answer in this case is 2. So if we look at our second example here, 2/5 times 30, again we can get 2/5, we can go 2/5 plus 2/5 plus, and we can keep going 30 times. But that's doing that 30 times, that's going to be a bit tedious to calculate. So instead, we're going to get 30, we're going to split it into fifths, and we're going to obtain 2 of them. So let's try to figure this out visually. Let's put them into chunks of 5. I've purposely done 5 because in this case our denominator is 5. And I'm going to do this 5, 10. I'm going to keep doing this until we get 30. So we've got 5, 10, 15, 20, I'll go 25, and 30. Okay, so we have got 30, and we're going to chunk this up into 5 parts. Okay, so we want 5 parts. So I know it's easy to assume that, oh, I can do this. We can split it across like this, and there'll be 6 parts. We have to draw lines down like this, like so. So there's a 30, and we've split it into fifths. There's 1/5, 2/5, 3/5, 4/5, and 5/5. So how many are in each fifth? Well, we got 6 of them. And how many do we care about? Just 2. So we're going to look at these 2 fifths and just count how many are in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our answer in this case is 12. So 2/5 of 30 is 12. If it were to ask for 3/5, it would be 6, 12, it would be 18. If we'll ask for 4/5, it would be 24. Heck, if it will be asking for 5/5, it would be all of it, 30. 5/5 is 30, because 5/5 is the same as 1. And it's just going to be asking for one lot of 30. So another way of answering this question, this is one way, the addition way, which is tedious and will take long. This is another way, which is the visual way, which can sometimes take quite a while to do, especially if we're dealing with bigger numbers. Another way, and I did show this way in the previous video, is whenever you see the times and that number is just as it is, you can put 30 over 1 and just times the top 2 numbers. 2 times 30 is 60, and 5 times 1 is 5. And 60 over 5 is the improper fraction. We're just going to figure out how many 5s go into 60 in this case. Can't use a calculator in this case. 65 goes into 60 12 times, which is the same answer that we got here. So there's different methods, and this is what it means in the success criteria, the varied ways of getting the answer. They're all going to be the same. You can choose which method you prefer. Remember using your calculator to double check to see if your answer is correct and not just using it for a solution. Right now, we can now see real life context of how this applies. We have a survey that's been conducted. So a survey of 40 people on what their favorite music genre is. And of those 40 people, 7/8 of them chose pop. How many people is this? What this is saying is that from the 40 people, if you were to grab 8 of them, right, you take 8 from there, right, so 8 people, of those 8 people, 7 of them liked pop, hence the fraction 7/8. So 8 people get taken out, and from those 8 people, 7 of them like pop. And then you do this again. From the 8 people, 7 of them like pop. So you take another 8, and then 7 of them like pop, or 7/8 of them like pop. And then you keep doing this until we run out of people to take a chunk of 8 from. And then the question is, how many people like pop? So let's first figure out how many 8s there are in 40. So 8 goes into 40 5 times. 8, 16, 24, 32, 40. So I would be drawing this arrow out 5 times. So we've got 1, 2, 3, 4, 5, 8, 8, 8, 8, 8, or 8, 16, 24, 32, 40. And from each group that has been taken out, 7 of them like pop. So we've got 7 here, another 7, another 7, another 7, another 7. How many 7s is that? Well, that's 7 times 5. There's 5 lots. So 7 times 5. So 7 plus 7 plus 7 plus 7 plus 7 from those 5 7s here. That would give us 35. So from the 40 people, 35 of them like pop, because that's 7 8s. Okay, the other way, 7 8s times 40. That's the other way you can do that. Remember, when we see if we're using a fraction or getting a proportion of something from a quantity, we can use the times symbol. And again, this will give us the same answer of 35. Okay, second last example. Let's look at another context question. A builder estimates that it will take 112 hours to build a house, and 3/8 of the time will be spent building the roof. How many hours is this? This is a bit cut off there accidentally. How many hours is this? So we know that to build a house takes 112 hours. And so for every chunk that we split this up into 8 parts, or 8 hours, 3 of those hours will be dedicated to the roof. So we don't know what the additional 5 is dedicated to. It could be anything else, but we know that for every 8 hours spent, 3 of the hours will be distributed to building the roof. And we keep doing this until all the 112 hours have been spent. So the first thing we want to know is, if we're going to take 8 hours out and another 8 hours out and another 8 hours out and keep going, how many times this is? Well, we just have to find out how many times does 8 go into 112. So 112 divided by 8 is 14. So this gets broken down into 14 sections, or you'll see me draw an arrow out 14 times. And then from these little 8-hour chunks that are taken out, 3 of them are dedicated to the roof. So we have 3 hours for the roof, another 3 for the roof, another 3, and this keeps going until all 14 chunks get their respective 3 hours. So how many hours we have contributed to the roof? Well, we're just, oops, that should be 14. We're just figuring out how many lots of 3 hours we need. That's 14, based on finding out how many chunks there were of 8 in 112 there was to begin with. So 3 times 14 gives us 42. Or in other words, 3/8 of 112 hours, which is nearly half. 3/8 is very close to half, is 42. Okay, let's see what half of 112 is. Half of 112 is 56. This is very close to a half. So 42 is very close to 56, comparatively speaking, to 112. Again, you could have just done 3/8 times 112, put that over 1, and then figure out what this is. Whatever answer you get, you simplify. But I find this way much easier to understand and to digest, and the maths behind it is actually quite simple. Obviously, we'll be using the calculator, but you do get smaller numbers to deal with. And the last question, and the last example, is question 16 from the skill. Which fraction of its amount is largest? So just be careful as keynotes. Some of the questions says smallest, other questions says largest. We're looking for the largest amount. So in this case here, we've got 25 and we're finding 1/5 of 25. So 25, if we're going to split this up into 5 parts, each part is going to have 5 in this. Now, I know this because I know what 25 divided by 5 is. And from this, we just care about one of them. So this answer here is just 5. 3/4 of 8. 3/4 of 8. So we have 8. And we're going to split this up into 4 parts this time. How many go into each part? Well, this has to be 2. 2, 4, 6, 8. And from that, we care about 3 lots of them. So this is 1, 2, 3. How many all up? 2, 4, 6. So far, this is bigger, so it can't be this one. 1/4 of 12. Let's get the number 12. Split this up into 4 parts. And each part has 3, 3, 6, 9, 12. How you work that out is just get the whole quantity and divide it by whatever the denominator is. So 12 divided by 4 is 3, so I know each chunk has 3. And from them, I care about just one of them, which is just 3. So it can't be this one. So far, 6 is winning. And 1/3 of 15. So 15 split up. We have 5, 5, 5. We only care about one of them, which is 5. So from that, the biggest one is this one because it's 6. So 3/4 of 8, even though this 8 is a small amount in comparison to 25, to 12, and to 15, 3/4 of it is greater in comparison to 1/5 of 25, 1/4 of 12, and 1/3 of 15. So our answer will be this one. And that concludes this video for this skill. Go ahead and attempt this skill on Essential Assessment, and I'll see you in the next video. Bye-bye.